Fission and fusion are two different nuclear processes that release energy by altering the nucleus of an atom. Here's a detailed comparison of fission and fusion, along with their limitations. Nuclear fission. 1. Process. Fission involves splitting a heavy nucleus, usually uranium-235 or plutonium-239, into two smaller nuclei, along with the release of energy and several neutrons. 2. Energy release. The energy released in fission is the result of the conversion of a small amount of mass into energy, as described by Einstein's equation, E=mc². 3. Control. Fission reactions can be controlled by adjusting the number of neutrons in the system. 3. This control is crucial for the sustained energy release in nuclear reactors. 4. Applications. Fission is the process behind nuclear power plants and nuclear weapons. 5. Limitations. Radioactive waste. Fission produces radioactive waste materials that remain hazardous for thousands of years. Proper disposal and containment of these materials are challenging. Nuclear accidents. If not controlled properly, fission reactions can lead to catastrophic accidents, as seen in the Chernobyl and Fukushima disasters. Limited fuel supply. The most common fuel for fission, uranium-235, is finite and may eventually become scarce. This creates concerns about long-term sustainability. Nuclear fusion. 1. Process. Fusion involves combining two light atomic nuclei, such as isotopes of hydrogen, deuterium and tritium, to form a heavier nucleus. 1. This process releases energy and is the same reaction that powers the sun. 2. Energy release. Fusion releases energy because the combined nucleus has slightly less mass than the sum of the individual nuclei, again according to Einstein's equation. 3. Control. Fusion reactions require extremely high temperatures and pressures to overcome the electrostatic repulsion between positively charged nuclei. 3. Achieving and maintaining these conditions for a sustained reaction is challenging. 4. Applications. Fusion has the potential to provide a nearly limitless and clean energy source for the future, with minimal environmental impact. 5. Limitations. Temperature and pressure. The extreme conditions required for fusion are difficult and expensive to create and maintain. Current methods often require more energy input than the energy output from fusion. Containment. The high-energy particles produced during fusion can damage the containment materials, making the design of a reliable fusion reactor challenging. Tritium supply. Tritium, one of the fuels used in fusion reactions, is radioactive and not naturally abundant. Developing a sustainable and safe supply of tritium is a concern. In summary, fission involves splitting heavy nuclei, while fusion involves combining light nuclei. Both processes have unique advantages and challenges. Fission is currently used for nuclear energy but produces radioactive waste and has safety concerns. Fusion holds the promise of clean, abundant energy but requires overcoming significant technical challenges to become a practical and viable energy source.